Alright, so I am going to go over questions 11 through 20 with you. Here we go. So, starting off in the sequence above, the same positive integer is added to each term, starting with x to obtain the next term. What is the sum of the first 5? So this is one of those two-part process problems. So starting off, I know I added something to get here and then the same exact number to get here. But you'll notice that from 10 to 18, I would have to add 8. Therefore, if I'm going to add twice to get to 8, I must have added 4 and must have added 4. So now I know what the numbers should be. Honestly, in this case, it's easier to figure out what the numbers are to find the sum of the first 5 than to try and use a formula. So I know that 10, 14, 18 are the last 3 numbers, and going backwards, I would subtract 4, so this would be 6, and subtract 4, hopefully that's 2. Hopefully I got all the numbers right, and then all you're going to do is add 2 plus 6 plus 10 plus 14 plus 18, and we get 50. So the answer is D as in dog. Alright, next question. 12. In the plane, they are the coordinates of 2 points on a circle. Alright, so some of you may feel most comfortable drawing out. And it doesn't have to be a great sketch, but it may help. 3, 2, so that'd be about here. 13, 2, that would be here. And then on the PSAT itself, I probably don't write as much, but I do try to show some work to make it a little easier. So these are 2 points on a circle. If the center of the circle, which we don't actually know where the center is, has coordinates a, 2, what's the value of a? So, alright, so now I'm going to look at the center, which was a, 2. So what's interesting is they gave you this problem. SAT problems should only take about a minute, at most a minute and a half. So, as a result, I can tell that there must be some kind of trick to this question. They're essentially telling you right here, oopsie, that this is a, 2. And if that's a, 2, and you notice that these are all on a y value of 2, what you're guaranteed is that those endpoints in blue have to be endpoints of a diameter. Why is that important? Because then that helps me find the radius. From here to here would be a radius. That's supposed to be an R. And then from here to here would be a radius. So, from 3 all the way to 13 would be a diameter. That distance is 10. The radius then is only 5. And the answer to the question is not 5. They want to know what A is. Well, remember, I'm going to make the drawing a little bit better. 3, 2 is here. And then this is supposed to be the center, and that's at A, 2. And remember, we said the radius, so from a point on the circle to the center is always the same distance, that radius. So I know that if I take 3 plus the radius, which is 5, that'll get me the A value. So the A value is actually 8. Most people will answer 5 for this. That's because it's one of those two-part problems. Number 13, the graph above shows the percent of fabric distributed each year to retailers. Alright, so, sorry, that might have seemed a little choppy. I paused it because I realized I don't need to read the question to you guys. I just need to go through the question with you. So, I noticed that there's an X inside of the pie chart. So a pie chart always adds up to 100%. And so if I notice that there's 60-80% already shown, then I know that this has to be 20%. And remember, you don't base it off of the size. You base it off of the actual numbers. Be really careful with that. It happens a lot that people look at it and say, oh, it looks like it's 20, therefore it's 20. It's actually more so because the numbers add up to 80. Alright, now that we know that, the question that they're actually asking you is the increase from 2000 to 2005 of retailer D. So this is retailer D here. They do 20%. So what you're going to do is you want to see how much more they gain. So that would be 2,800,000. And part D, or retailer D, only did 20% of that. And then you want to subtract the 15 let's see, 1.5 million, I believe, is the number. There we go. Times 0.2. So really what you can do, in a sense, you can factor out the 0.2, and then you could do in your calculator the 2,800,000 minus the 1,500,000, and then multiply it by 0.2. So 28. So when you do that, you get 260,000. Number 4. So I think this one's going to be a little bit difficult to explain. This is the key. A and B have to be integers. What that means is you can use positive or negative numbers in 0, but they have to be whole numbers. So these are your integers. That's actually a really important piece of this little puzzle here. So we get 14/3 is equal to A over B, and in the end they want to know what A plus B is. So the fact that I have two variables, what I'm going to do is figure out how to write one in terms of the other, and obviously the easier way is to multiply both sides by B. So I end up with that A is equal to 14/3 B. Okay? So what I'm going to do is, this is what I'm looking for. This is the answer that I'm physically looking for. Now, I know that if we have two integers, then the sum of the two integers also has to be an integer. What that tells me is I can't add the two numbers and get a decimal. Alright, so A, I'm going to use my answer right here for A, and I get 14/3 B plus B. Well, 14/3 B plus B, that says 14, sorry about that. I'm going to get a common denominator, so I'm going to multiply this by 3 over 3. So I get 14B plus 3B all over 3. So you end up with this weird thing, 17B over 3. Now this is actually going to be equal to the sum, that sum of A plus B. Now what's interesting is what I'm going to do here is, number one, remember we said that the answer, the sum, has to be an integer. So that means that somehow, some way, this can't be a fraction when I'm all done. What that tells me is the numbers that I can put in for B have to be multiples of 3. Why? Because when I do 17/3 times 3, that's what cancels that denominator. Okay? So I'm not really solving for B. I'm solving for the sum. So 17 would be a sum. Notice that all your answer choices are positive. That's why I'm not even trying the negative number. So then I would do 17/3 times 6. And I get 34. And I do 17/3 times, and honestly I'm doing this with the calculator. For you guys right now on the board here, I'm showing it to you as this, because now you can start to see that there's a pattern. Here's 17 times 1. This is 17 times 2. This is 17 times 3. But really what I was doing is putting in values for B to make that work. So then I'm just going to keep doing multiples of 17 until I see a value that's up there. And 51, I'm getting close to the number. 17 times 4 gives me 68, and that's the only number up there that I've seen so far, so the answer is A. So that kind of understanding of integers is what helps me through this problem. 15. Alright, so this guy, you have 6 participants playing 2 matches against each other. What's the total number of matches? So honestly, a lot of these, the easiest way to do it is you just write down the people. So there are the 6 people. Player 1 won't play against themselves. They'll play player 2, player 3, player 4, player 5, and player 6. And that's a total of 5 matches, but they're going to play that twice. So I'm going to, in the end up having to multiply that by 2. Player 2, they can't play player 1 because we counted it already right here. So therefore we start with player 3, player 4, player 5, player 6. And that's 4 matches. Here, same reason why we don't use 1 and 2. I would have to start from 4, 5, and 6. That's 3 matches. Notice what's happening. And then next, it's player 4, so it's only 5 and 6. Player 5 plays player 6. Player 6 been counted everywhere. So what you'll notice is the first round of matches, you have 5 plus 4 plus 3 plus 2 plus 1. And yes, I said plus, not multiply. For anyone that's taken statistics, you may think that you're supposed to multiply these. And that gives you a total of 15 matches. But remember, we're playing 2 matches each, and that gives us 30. Letter C. Alright, next one. Alright. So this type of question, it's honestly just easiest to pick a number that's going to work. So you're between -1 and 0. Because you know only one of these can be true as being the least, you can pretty much guarantee that you can pick a number that satisfies that first inequality, a number between -1 and 0, -1/2, and you should be able to substitute that in and see which one's going to be the smallest number. Now, smallest number, be really careful when you look at negative numbers. They go backwards. And this side over here, the left side, is the smallest numbers. Alright, so what we're going to do, we're going to take -1/2. We're just going to write all the answers in front. So this would be 1/2. -1/2, oh sorry, negative x. Yeah, that's correct. Alright, 1 over x just means reciprocal, so that would be -2. -1 over x would be reciprocal and multiplied by a negative, which would be 2. 1 over x squared would be x squared, but then take the reciprocal of it, so that's 1/4, so that's 4. And then 1 over x cubed would be take x cubed, which would be -1/8. Let me kind of show you that one. So cube that. That's -1/8. When you divide by -1/8, when you divide by a fraction, it's the same as taking the numerator here and multiplying it by the reciprocal. And you get -8. So the answer to this guy is E, and I simply did that just by substituting in values. Notice again, we could have started with letter E because we're checking values, and you would have been done a little bit quicker. Number 17. Alright, so we have here that you have the perimeter of a right triangle is equal to the perimeter of an isosceles triangle. Alright, so I'm going to draw 2 triangles, a right triangle and an isosceles triangle. So you have to know your triangle definitions. So these two are the same in an isosceles triangle, but in my right triangle it didn't say anything about the sides being the same. The lengths of the legs of the right triangle, so the legs are the ones right here. I shouldn't use that mark. This one and this one, these are their legs because they make the 90-degree angle. The lengths of the legs of the right triangle are 6 and 8. So I'm going to call this one 6. I'm going to call this one 8. If you know your Pythagorean theorem really well and your triplets, we know that that side has to be 10. If you don't know that, then you would do 6 squared plus 8 squared is equal to c squared, and this side here being c because it's the hypotenuse across from the right angle. Alright, and we get 6 squared is 36, 64 equals c squared, 100 is equal to c squared, therefore c is equal to the square root of 100. How do I do that? You do that right here, and then c is equal to 10. Alright, so I actually have the perimeter 10 plus 8. So perimeter is just adding up all the sides. So 6 plus 8 plus 10. So I have 18 plus 6, so 24. Alright, the length of each side of the isosceles is an integer. What is the greatest possible length for one of the sides of the isosceles triangle? Alright, so we know that this guy has to be 24 when we're all said and done. We have, let's just call this x, let's call this x, let's call this y. I don't really know if that's the best way to do it, but I know if I add my 2 x's plus my y, that should give me 24. And then same thing like the other question, I'm just going to check values. Now, what you want to know is they want it to be the length for the biggest, it has to be the greatest possible length. So if I put 10 into here, I'm going to show you the two ways that you could have put in 10. We could put 10 here, which would mean that the other side is 4. Or I could put the 10 here, which would mean that the other side is 7. So I hope you understand why, but I really don't have to worry about substituting it into the y every single time. It's the fact that you have that double x, the 2x. I am going to, actually, I'll just go and put them into each just to make sure you understand. Alright, so 10 works. It's a possible side, so that works, but remember we want the greatest possible. That's the tricky thing. So if you got all excited and you're like, oh, 10 works, and you choose that answer, it might not be the right answer. So 10 worked. I'm going to put that back in blue, so I'm going to change my color for each answer choice I try. So next, let's try an orange answer choice B, that's 11. So 11 could go here, which would give me 22, so this side is 2. If I put 11 here, look what happens with 11. Then I have 13 left. And remember again that each side is an integer, so this doesn't even work. If I have 13 left, this would have to be 6.5. And we're not allowed to have decimals for our length of side. So 11 does work, but we don't have to worry about it for a possible side of y. That kind of shows you why I always substitute it into the x and why I don't really need to check the y. But because it worked, it's a possible length, it doesn't say which side, whether it's one of the congruent sides, which are called the, the legs of the isosceles triangle, I think, versus right here, that base. It didn't say which side it had to be. Alright, 14. So if I substitute 14 into y, then that leaves me 10, so x would be 5. If I substitute 14 into here, it's too big, so that doesn't work. Alright guys, so let's rewind for a second because I got pulled away and I can't actually remember where I was when we were talking about the problem. I will go back through, and it might be a little repetitive as to why we can use 10. So if these two sides are 10, then that would leave this side to be 4. And that triangle is still possible. But, let's see. Let's do 11. So 11, if this side, oh, and I should actually go the other way, which would be if this side was 10, let's see, then these sides would be 7, and those triangles are still possible. Alright, now let's go to 11. If this is 11 and this is 11, then this side would be 2, and the triangle's still possible. It would be really, really skinny like that. Okay? Alright. Then, if this side was 11, these would be 6.5, but we said they had to be integers, so that's actually not possible. Alright, so we know that those work. So far the answer would be B because that's the biggest one. So let's use 14. So if this side was 14, that would leave me 10 left to make a perimeter of 24, and that would be this. Problem with this picture is the fact that if this side's 14, this side is 5, and this side is 5, the two sides of the triangle will actually never meet. So there's a rule that the sum of the two smaller sides, 5 and 10, have to be greater than the third side. And in this case, 10, it's not greater than 14, so that wouldn't work. But we can try another way, which would be if your x's were 14. So let's say if this was 14 and this was 14, well, the problem is the perimeter's already 28, which is bigger than the 24 and wouldn't leave us room for y. So 14 doesn't work. That should make sense as to why those won't work, so the answer has to be B as in boy. This one's a little bit tricky. All of these are always, those less than type questions are always a little bit interesting, let's say. So, what it says here is that if we know that x is less than y is less than 0, there's a few things. First of all, x is less than y, but if they're less than 0, it tells me that both of these numbers have to be negative. One way you can try the problem is picking values, and you want to be a little bit careful. We can pick some random values like x is -5 and y is -3. But then you also want to think about fractions. So -4/5 would be close to -1. -1/5 would be closer to 0, so that would be the bigger number. So you want to also think about using fractions. I'm going to go through each of these. As you can see, the answer is E. I'm going to actually go through each of these to discuss what we can figure out. So let's look at this guy. So we're going x plus 1 is less than y plus 2. So let's just think this through just using the words small and big. So this is actually the smaller number, and this is the bigger number. So take the smaller number, only add 1, but take the bigger number and add 2. Do you notice that to the bigger number you're always adding something bigger? So number 1, no matter what, will be true. You can actually test. You can try every single set of numbers and test it to see what happens. The other one that I think is interesting is actually this guy. X over y greater than 1. So that's the third guy. So you're taking, first of all, you're taking a negative number and dividing it by a negative number. So now, number 1, I know the number is going to be positive. We know about those negative numbers because they're right here. Next thing, you're taking some small number, and we can actually try it. It's the fact that your negative numbers, the way that they work out, the smaller the negative number, the bigger the absolute value is. What I mean by that is if we didn't look at the negatives, 5 would actually be bigger than 3. Because the negatives cancel and we aren't looking at the negative numbers anymore, you're actually going to end up with a bigger number on top, a smaller number on bottom, kind of like that 5 and that 3. What that means is anytime you take a bigger number up top and a smaller number than on bottom, it's always bigger than 1. So we know that the third one's true. The middle one, I think I might have a little bit more trouble explaining. 3x less than 2y. So you're taking a negative number here, and you're making it more negative. What do I mean by that? You're multiplying it by 3, it makes a negative number more negative, kind of looking at a number line. Here's -5, and if you multiply it by 3, it makes it go this way 3 times as far. Okay? Here, you're only making it more negative by 2. So what happens is, let's see, maybe the best way to explain it is using actual numbers. So if I have -5 here, and I multiply it by 3, it makes it more negative by 3 times. If I use the number -3 on this side as the y value and I double it, it makes it more negative, but not enough to overpower the 3x. This is probably the worst explanation I've ever given, which means the fact that it's more negative, it stays that the 3x is smaller. Again, sorry, I don't believe that this is my best work here, but that's the reason why letter E works. I started off talking about these fractions, and I actually haven't used them. Fractions behave a little bit differently, so if you look at values between 0 and 1, anytime they give you the option to pick values, I always think about the numbers between 0 and 1. So fraction numbers between 0 and 1, and I always use them in this type of question to make sure that they behave the same way as all the other numbers. So you can actually try 1, 2, and 3 and use these numbers to see what happens. You'll notice that they're all true also. Number 19, there are n more males. Okay, so this one had a lot of males, females, and it had a lot of weird variables. I thought it was interesting. So I'm going to use F for female, but for males, it said to use the letter K, which I thought was weird. I almost feel like they're just trying to confuse you. Now it says there are n more males than females. Alright, so then n more males than females. So there's more males. That's actually how I always figure out the equations, because I get them confused too. So n more males makes you want to do this. N more males than females, and that's actually incorrect. So if you think about, if these are the males and these are the females, you actually are saying that there's more females because you're adding a number to the males right here. And if you don't understand that, you can actually just pick real numbers and see what happens. Alright, so what we're going to do is write it correctly. So in the end, there should be more males, and males are K. If you take the females and add N to it, that'll get you how many males you have, because there's more males. That's why we add the N to the female. Alright, then it says what fraction of the employees are male. So fraction means I want males, number of males on top over the total. And what we get is males are K. The totals would be the males plus the females, but I'm going to use what we have there, the fact that females are actually K minus N. So K over the males plus the females, which are K minus N, and you end up with K over 2K minus N, which is C. Last guy, number 20. So here we go. We're not going to use the top and the bottom, so it says the surface area is 2 pi RH, and it says that the surface area is 70 pi. Things that I can do right now, I know that in the end I'll probably end up canceling those pi's, and we get 2RH is equal to 70. I'm sorry. I can even get that RH is equal to 35. So that's just things that I'm doing in my head already. If the volume, alright, so what's the volume of the cylinder? Well, the volume would be pi r squared h. So what I'm going to do is I'm actually going to find how much my h is here, because there's two variables. Then I'm going to need to solve for h in one of them, and then I'm going to put that in for h right here. So volume is equal to pi r squared times h, which is 35 over r. So what do we get? We get that r squared divided by one of the r's. We'll cancel the squared and cancel that r completely. So we get 35 pi r, which would be A. And there's number 20. There you go.